All right, today we're moving on to lesson 2.3 on rotations. I think that you will think rotations are just as simple as the last two transformations we've done. So let's just jump right into it. So rotation is a transformation that's turned around a fixed point. Excuse me. So rotation is just a turn. So if you were to say this was your pre-image and I rotated it this way, this would be counterclockwise, so in the opposite direction from a clock. Okay. Or if I move this way, it would be clockwise. I'm moving in the same direction a clock would move. Every coordinate that you move over is 90 degrees. So from this smiley face to this smiley face, you would say that I rotated 90 degrees counterclockwise. If I move twice, that's 290 degrees. So this one would be 180 degrees clockwise. If I move 3 times, that's 390 degrees. So that takes me 270 degrees clockwise. And then if I move all the way back around, it's 4 times, it's 490 degrees. That gets me at 360 degrees. Okay. So let's just jump into it. These are going to have rules just like the reflections did, and so I think you'll think it's pretty simple. So we're going to start with 90 degrees clockwise. 90 degrees clockwise is the same thing as 270 counterclockwise. I don't know that you're ever going to see us call it 270 counterclockwise. We're going to call it 90 clockwise. Okay, so I'm just going to talk about this problem as if it's 90 clockwise. If XY is rotated 90 degrees clockwise, then its image is the point y negative x. So y negative x. Okay, so all we're going to do, I've already written down your pre-image coordinates. I came over here and counted them on my graph. Is you're going to switch the order, change the sign of the back number. Okay, that's all my rule says to do. We practiced this a lot with reflections on our last video, and so this one should be just the same way. So let's start with A prime, my image. It says to switch the order, change the sign of the second number. Okay, so let's keep doing that. B prime, switch the order, change the sign of the second number. And C prime, change the order, switch the sign of the second number. Okay, that color looks like it might be hard to see. Okay, so let's graph that real quick. My A prime is at 1, negative 3. There is A prime. My B prime is at 4, negative 3. There is my B prime. And my C prime is at 1, negative 1. There is my C prime. Again, I can connect these like always. And we can say that that has been rotated 90 degrees clockwise. Notice the orientation has changed. My point B has come here. A has rotated back this way, and C is kind of staying close to where it's at because my center of rotation is the origin. So that middle point on my graph is what I'm rotating about. Okay, let's do 2 more of those. Next, we're going to look at 180 degrees. Notice 180 can be clockwise or counterclockwise. And let's think about that for a second. If I'm going 180 degrees, it doesn't matter which way I go to get there. I'm just going to get there. If I turn myself around backwards, I can go to the right or I can go to the left, but I'm still just turning around backwards. Okay, so clockwise or counterclockwise. The rule says negative x, negative y. So notice on this one, the order doesn't change. All that changes is the sign. Okay, so A was 3, 1. I'm going to change the sign of both numbers, negative 3, negative 1. B was 3, 4. I'm going to change the sign of both numbers, negative 3, negative 4. And C was 1, 1. And now it's negative 1, negative 1. Okay, I'm ready to graph. Negative 3, negative 1. There's my A prime. Negative 3, negative 4. There is my B prime. And negative 1, negative 1, there is my C prime. Again, I can tell by glancing at this that it is rotated 180 degrees because it jumps over 2 quadrants, 1, 2. Okay, and remember each quadrant takes me over 90 degrees. All right, last example. 270 clockwise or 90 counterclockwise. Again, you're going to hear us talk about it in increments of 90 usually. So if I want you to go 270 clockwise, my directions are going to say go 90 counterclockwise. But I do want you to know that those are the same thing. So they do have the same rule. Okay, so for example, I've gone ahead and written down your pre-image coordinates, and we're just going to write down the rule. So it tells us back here that the rule is negative yx. So on this one, you'll notice the order has switched, and the sign of the front number is going to change. Okay, so A was 3, 1. I'm going to switch the order and change the sign of my front number. So it'll become negative 1, 3. B, it was 3, 4. Switch the order, change the sign of the front number, negative 4, 3. And C, changing the order doesn't do me much good, but changing the sign of the front number, negative 1, 1. All right, I'm ready to graph it. So we've got negative 1, this way, and then positive 3. There is my A prime. B prime is negative 4, 3. And C prime is negative 1, 1. There it is. Again, that's 90 degrees counterclockwise. It jumped over one quadrant this way. Or if you wanted to count it clockwise, you could say that it jumped over 1, 2, 3 quadrants going clockwise. And that's why it's 3 90s. 90 times 3 is 270 degrees clockwise. Okay, I do have one more thing to tell you on this video. And so you've seen this paper before, and I told you I'd come back and fill it in later. So here's, the time has arrived. So let's talk about this, order and magnitude. Order and magnitude have a lot to do with something called rotational symmetry. And so if I ask you about order and magnitude, here's what I'm asking you about. Order is the number of rotations less than 360 degrees, including 0 degrees. Okay, and then magnitude is the measure of each angle of rotation. Okay, so right now that just sounds like a bunch of mumbo jumbo, but here's what I mean by that. Order is the number of rotations less than 360. Here's what I mean. Here's an example. This is a 5-sided shape. We talked about that in Unit 1. It's a pentagon. If I want to determine the order, I'm asking you how many times can I turn this pentagon so that it looks exactly like this. Okay, here's what I mean. I'm going to put a dot right here letting you know this is where I started. It tells me to include 0 degrees, meaning include before I've rotated it at all. So there's my first time I look at this. That's the first way it's oriented. When I turn my paper this way, does that pentagon still look the same? Now, we're going to pretend, and I'm so sorry, my printer isn't always the best, that all of these sides are the same, okay? They are the same on my computer, just for the record, but when I print it out, it gets distorted. So we're going to pretend those are all the same. So when I turn this pentagon this way, hopefully you're telling me, yep, looks the same. So there's my turn number 2. All right, let's turn it again. Look at this one. Now this vertex is at the top. Does it still look the same? Yes. There's turn number 3. Here's number 4. Looks the same. And here's number 5. Looks the same. It says less than 360 degrees, meaning when I turn it all the way back around, I'm not going to count this one because I've already counted it. So my order of this pentagon is 5. I can turn it 5 different ways where it looks exactly the same. Okay, and then the magnitude, it says, is the measure of each angle of rotation. To find the magnitude, you're just going to do 360 divided by whatever your order is. So, for example, on this problem, you would do 360 divided by 5, which I believe is 72, but let me make sure. Yep, 72. So the magnitude is 72, meaning each time you turn it, you're turning your paper 72 degrees. I do want to show you one more thing. Some people think, okay, well, then the magnitude or the order is just however many sides it has. And so I want to prove you wrong real quick. So let's look at this piece of paper I have. We're just looking at it as a piece of paper. I've got this rectangle, right? If I'm looking at this rectangle this way, you could say there's my first turn. Okay, here's my rectangle. When I turn it this way, it doesn't look exactly the same anymore. It's oriented in a different direction. So I can't count this. Okay, this is not the same as this. Different, different. Okay, so I'm not going to get the same until I get it totally upside down. There's turn 2. And turn it again. That's no good. It's not the same. And then back where I started. So the order of a rectangle is just 2. Okay. Let's look at the order of a square. Let's see if I can find something square. Here's a Post-it note. This is perfectly square. So when I start here, let's put an X letting me know this is where I'm starting. There's my first one. 1. I can turn it this way. There's 2. Still the same. There's 3. There's 4. Then I'm back where I started. So on a square, the order is 4, but the magnitude is 360 divided by the order, so the magnitude is 90 degrees. But remember, on a rectangle, which is also a 4-sided shape, my order is only 2 because it only has the same orientation when it's this way and when it's upside down. Okay, so don't get bogged down on, oh, it's how many sides it has. It totally depends on how the shape looks. Okay, I think that should be plenty to get you through your homework for today. See you later.